The first time Galileo pointed his telescope at Saturn, he called its rings ears. Today, we know them as a 280,000-kilometer-wide debris disk made of almost nothing. But the planet itself is the solar system's ghost. It is so light it would float in a bathtub if you could find a bathtub large enough. Let's find out why. Here is the puzzle. Saturn is 9.5 times wider than Earth, but only 95 times its mass. Spread that mass out, and you get 0.687 grams per cubic centimeter lighter than water. Jupiter is built from the same hydrogen and helium, yet it is nearly twice as dense. Same ingredients, different answer. Hold that, because the reason also explains the rings. Here is the data on Saturn. A diameter of 116,460 kilometers, almost 10 times wider than Earth. But its mass is only 95 times Earth's. That gives it a density of 0.687 grams per cubic centimeter. Water is 1.0. Saturn is literally lighter than a liquid. It is mostly hydrogen and helium, the same stuff as the Sun, just spread out into a giant, fluffy sphere. To find Saturn, you must travel 9.5 times farther from the Sun than Earth. That is 1.4 billion kilometers. At this distance, sunlight is 100 times dimmer than what we enjoy. The Sun itself would look like a bright, unblinking star in Saturn's sky. This is a cold, dark world, but it is far from dead. It is wrapped in bands of clouds, and those clouds are moving at incredible speeds. So why are Saturn's rings there and not a single moon? The answer is the Roche limit. A moon orbiting closer to Saturn than about 2.5 times Saturn's radius feels a tidal pull so strong that it tears the moon apart. If a moon drifts inside this line, it gets pulled into a stream of rubble. That is almost certainly how the rings formed. A moon got too close, and the debris got caught in a gravitational no-man's land. The rings are not static. Watch the tiny moons, Pan and Prometheus, as they orbit inside the rings. Their gravity pushes and pulls on the ring particles, carving gaps and sharpening edges. They are like cosmic sheepdogs, keeping the herd together. Without them, the rings would spread out and diffuse into a faint halo over millions of years. Up close, the rings are not solid sheets. They are a swarm of particles. Most are chunks between a centimeter and a few meters, snowballs and boulders. True dust is rare in the main rings and lives mostly in the faint outer ones. The rings are 99% water ice, with a hint of rock. If you gathered all the ring material together, it would make a moon about 250 kilometers across, smaller than some of Saturn's own icy moons. Let's compare Saturn to our home world. Earth is dense and rocky. Saturn is a gas giant. Saturn's radius is 9.5 times Earth's. Its mass is 95 times Earth's. But look at gravity. Earth's surface gravity is 9.8 meters per second squared. Saturn's at the cloud tops is 10.4. Because Saturn is so puffy, its gravity pulls surprisingly gently for its size. If you could stand on a cloud top, you would feel about the same weight as on Earth. The difference is, you would have no solid ground beneath you. Check your understanding. Saturn's rings are mostly made of what material? Solid sheets of volcanic rock, water ice ranging from dust to boulders, liquid methane or plasma. Pause the video and commit to an answer. The correct answer is B. The rings are 99% pure water ice. They are bright and shiny not because they are solid, but because they are countless tiny mirrors reflecting sunlight back at us. If they were made of rock, they would be as dark as charcoal and almost invisible from Earth. First key fact, Saturn's density is the lowest of any planet. It is made almost entirely of the lightest elements, hydrogen and helium, making it a cosmic lightweight. Second, the rings are not permanent. They are a temporary debris disk, shredded by tides and sculpted by shepherd moons. They may not have been here when the dinosaurs roamed, and they will eventually fade away. Third, despite being the lightest planet, Saturn is a giant. It is a gravity well, a storm factory, and a ring system so vast it would stretch from Earth to the Moon. Next, we dive into the moons of Saturn, Titan, Enceladus, and the icy family that orbit inside the planet's giant magnetosphere.